that the course will cover concepts. What is the way to introduce the concept, new concept in the programming language? The way we will follow it is to use the interpreters. So that means that we learn a new concept by implementing an interpreter. So whenever we have a new concept, that will be a new interpreter that will show us the meaning of the concept itself. The language that it will implement we'll call curly language, even though the language keeps changing, so it will be many variants of the curly language. The language that we will be using for the building interpreters is called plate language. This is a variant of a racket language. Historically, racket was built from Lisp, actually a version of Lisp scheme, and the plate is built in racket. So what is a racket? Racket is a programming language, but not only one programming language, it is a family of programming languages. A language also for creating programming languages. So one of the languages that is created in racket is a plate language. When you say plate, there is a T at the end, but play is a shortcut for programming languages, application, and interpreters, which is a book that will follow for this course. The T that is at the end of the language plate stands for a typed programming language. Looking at the racket and the version of the language we want to use, we will set up the hashtag language to be plate. And then we follow some of the examples. That means when you install Dr. Racket, use the latest version, you want also to import the package for the plate. Here are some of the examples that you want to follow and practice in plate. Plate tutorial is available and you want to look at that one as well. So it is showing the introduction for the plate language. Some of the previews for the plate language. Look at the parentheses. This is prefix notation that is used for the plate language. For the function f with the argument x, it is in the parentheses f and x. So that follows the rule for the addition. So operation plus is a function that will be applied to numbers 1 and 2. And similarly, for the expression 1 plus 2 times 3 will be showing in the plate as inside the parentheses plus 1, and the second argument is a multiplication of 2 and 3. If you want to define s as value 6, we want to use a definition, so define as 6 inside the parentheses. For the function f of x, we want to define it as an expression x plus 1, so it will be a definition for f function with the argument x, and the function body is placed inside the parentheses. This is expression plus x1. So what are the data that are used in the plate language? Numbers and strings, booleans, symbols, and quoted lists. Let's look at those. Numbers and strings, as usual. Numbers with the decimal point. Here is the string inside the double quotes. Booleans, as usual, not maybe usual, but it is hashtag T, hashtag false, F. Symbols and quoted list, so they are preceded with a single quote for the symbol apple. So it's a different notation from the string. This is a single quoted apple, and this is unique data. It's not possible to break it down into the characters that are used in the string. Similarly for the list. So you want to try these examples in Dr. Racket with the plate language. We are going to use the back quote instead of the regular quote to express the S expressions. So now it will be, if you use the back quote X, it will show you the X itself, and then the list of with the elements plus X2 will be defined the following way. Please try those examples in Dr. Racket. And once again, I'm showing the Dr. Racket with the plate language and S expressions. Plate data types, to consider different data types that are composite data. So, for example, we want to express the shape, which could be either a circle or a rectangle. The circle will have a number type for the radius, and the rectangle will have two numbers for the width and height. Then we want to follow what is the area of the particular shape. That will be defined as a function. Then we will check what is the argument S, what kind of shape we have. If it is a circle with the radius r, then the calculation for the area will be multiply 3.14 with squared r. And for the rectangle with the width and height, we want to multiply width and height. Here are the test examples for the area of the circle with the radius 2 and for the area of the rectangle with the width and height 3 and 4. Data type and the function matches, which is obvious. Looking back at the shape type, we have the circle, rectangle, and maybe we want to have a composite shape that consists of the left and the right shape, which could be either a circle or rectangle. Now we can extend the area for this case, and then it will be adjacent shape with the left and right. We'll have the area of that one, which is the sum of the area of the left shape and the area of the right one. So looking back at the shape type, you see that shape is used as the left one and right one in the adjacent data type, but also in the area, when we find the area of the shape, we're looking for the area of the left one and the area of the right one to be added to get the area of the adjacent shape. And considering the course outline, we'll review first the functional programming and the plate language, and then continue introducing the interpreters to cover the state, the control, compilation, objects and classes, types, and hoping we'll finish with the macros. But if any of those concepts cannot be finished, and by the end we'll assign some students to have a final project. Starting from next week, I encourage you to work on homework 1 for Monday so we can discuss any questions and the plate language. This homework is due January 24th at noon. Please bring the questions on Monday during the lecture time.